Hello and welcome to another Python coding tutorial episode. Today, first and foremost, I'd like you to look at this Venn diagram. As you can see, it represents two sets. Set A, containing the numbers 1, 2, 3, 4, 5 and 6, and set B, which contains only the values 4, 5 and 6. Now I'm sure many of you, myself included, would simply call set B a subset of set A. Well, would you know it? Also in Python we use the same term. B is a subset of set A. We can look at this in code quite quickly by writing out A equals 1, 2, 3, 4, 5 and 6. B is equal to 4, 5 and 6 alone. And then we can say B dot is subset of A. And this will return true. Why? Because B is a subset of set A. Of course, if we do it the other way around and say A dot is subset of B, this will return false, because A contains more values than are contained in the set B. Of course, every set is technically speaking a subset of itself. So we can say A dot is subset of A, and this will return true. And same thing with B. So A dot is subset of B, and that will also return true. Now, so far so good. But how many of you knew that there is also the reverse of what we've just seen? Namely, what is known as a superset. A superset in this case, looking back at our diagram which you can see here, would be our set A in relation to set B. In other words, a superset is a set that contains inside it another one. So we could write A dot is superset of B, and this time it will return true, because A is a superset of set B. Again, the same principle applies as for subsets, where each set is a superset of itself. So of course, A dot is superset of A will also return true. Now I hope all is good so far, but of course, if you have any questions, feel free to leave them in the comments down below, and I will get back to you as soon as possible. However now, for all of you who have followed me this far, I will give you a special insight. We can also apply the same rules of subset and superset using logic operators. So in this case, we can say A is greater or equal to B, and that will give us true. On the other hand, if we say B is greater or equal to A, this will give us false. What have we just written here? We've written that A is a superset of B, and that gives us true, because as we saw before, A contains B, whereas B is a superset of A gives us false. Of course, we can also say in the other way around, B is a subset, which we can write out as smaller or equal than. And if we say that B is small or equal to A, in other words, B is a subset of A, this will give us true. Of course, the opposite will give us false. Now, why did I show you the use of logic operators in this case? Well, because this allows us to perform one additional operation which the previous functions did not, and that is to identify whether A and B are proper subsets or proper supersets. Now the term proper means that we are excluding all the cases in which two sets are identical. So A will be a superset of itself, but it won't be a proper superset of itself, because A contains, of course, the same elements as A. So if we say A is greater or equal than A, in other words, A is a superset of A, that will give us true. But if we say A greater than A without the equals, in other words, A is a superset of A, this will give us false. Now this clearly allows us to distinguish between two sets which contain each other in a genuine way, and other cases in which two sets contain each other simply because they're identical. Of course, this works the other way around also with subsets, and we can say B is a subset of A, or better still, B is a subset of B in this example, and that will be true, but B will not be a proper subset of B, because B and B contain the same elements. With that, I thank you very much for watching, and as always, I wish you a wonderful week. Until next time, don't forget to like this video, as well as share it with your friends and subscribe to the channel. I hope you appreciate this series, and I ask for your help in ensuring that as many people get the joy of learning to code. As always, don't forget to check out my tutorials and challenges, and of course, until next time, happy coding!